Hello, everybody. So today we're going to continue our discussion in Chapter 7, Section 2. And this was a continuation of 7.1, where we started to learn about properties of exponents. And today is no exception to that. In the last video, you saw you saw where I introduced four more exponent properties to you, which were called the quotient, the power of a quotient, the zero, and the negative property. So I showed you some examples where we use the quotient and the power of a quotient property. Today I'm going to go ahead and show you some examples where we're going to use some of the other properties. So let's go ahead and get down to that. All right. So this is number 7. And what we're going to do is we're going to simplify this expression. Now, if you recall in the last video, I did say that in algebraic expressions, the final answer, the most simplified answer, is not allowed to have negative exponents. So you can't leave a final answer with negative exponents in it. You have to deal with those. Now, I'll show you how to deal with those. We're going to use this property, this negative property right here, which says that if we have a negative exponent, then we need to take the base and the power and move the whole thing down to the bottom of a fraction. Now, that also applies to a base and a power. If it's negative on the bottom of a fraction, you'll pick it up and bring it to the top. So let's look at our example here. So it says simplify, and it's negative. Now remember also that if you have the same base and they're being divided, you are allowed to subtract the powers. So this turns into c to the 2 minus 5 power. Well, that would give us c to the negative 3. But you are not allowed to leave a base with a power, and when the power is negative, you need to clean that up. And the way we clean it up is we make it move places. So if it is up top, it's going to go down to the bottom. If it's negative and it's on the bottom, it will go to the top. So it switches its place. So the next thing is going to be, we're going to make it 1 over c to the third. Now, the other thing that I want you to understand about that is that process of moving the base and the power down, because the negative is there. When you move it down, the power is no longer negative. It becomes positive. And so that is our final answer, 1 over c to the third power. Number 8 is going to be done in a similar fashion. You can see that both of these have a base of an 8. And they're both being divided. So when you have the same base and we're dividing them, you subtract the powers. So we're going to do 8, and then it's going to be the top minus the bottom power. So 3 minus 5. Now 3 minus 5 is negative 2. Now since that's a negative, so 8 to the negative second power, we are going to need to get that cleaned up. We can't leave it like that. So as in the last example, if the power is negative, the base and the power switch places. So it's going to go ahead and go down to the bottom of that fraction, and it becomes 1 over 8 to the second power. Now I could clean that up a little bit. Remember, 8 to the second power, or 8 squared, means 8 times 8, which is 64. So if you wanted to, you could write 1 over 64. Now I've got four, excuse me, I've got 4 more that I want to show you here. These are along the same lines as the last ones that we just did. However, it's a little bit more complicated because this x to the negative 4 is on the bottom. So there's 2 ways we could approach this. I'm actually going to show you both ways because it really is up to you as to which exponent rules you apply first and in which order, because they'll all work as long as you do them correctly. The first one that I would say in going along with what we just did is I said if you have a base and then the power is negative, if it's negative, it switches place. So if it's on top, it switches down to the bottom. But if it's on the bottom and it's negative, it will actually switch back up to the top. So I'm going to show that way. This whole thing is going to come back up here and then become positive. So what we're left with then is x to the third and then times x to the fourth. Notice there's nothing left on the bottom. Now you could put it over 1 if you wanted to keep that fraction, but it's not necessary. So now you can see that we have both of our x's are up on the in the numerator of what used to be a fraction. Now we're going to apply a product property that we had in a previous video, where when the bases are the same and you're multiplying them, you're going to add the powers together. So this would become x to the 7th power, because 3 plus 4 is 7. Now, an alternative way to do this, which is equally correct and will also get you the same answer, is to know that anytime you divide two things that have the same base, you subtract the powers. Okay, so since they're both x, we can go ahead and subtract them. I'm going to write it like this: x, and it's going to be to the 3 minus negative 4. So be careful, because the number on the bottom is a -4. So we end up with a minus negative, which I think most of us know should just turn into plus a positive. So it really just becomes 3 plus 4, which is x to the 7th. And as I told you, you end up with the exact same answer. And you should. If these rules are valid and they're all correct, then if you do it a different way, you should still end up with the correct answer. And we did. We got the same answer both ways. So either way is fine to do that. Now, looking at number 10 has 4 over 7 and then parentheses around it, and then to the -1. So remember, the quotient property told us that we can take this -1, and we can apply it to everything that's inside there, because it is division. Keep in mind, though, that if there's no power on the base, we need to put the ones in. And now this -1 is going to multiply that one, and it's going to multiply that one. So when I do that, I get 4 to the -1 and then over 7 to the -1. Huh. Well, what we end up with now are two bases who both have negative exponents. So what that means is the 4 has to come down to the bottom, but then at the same time, this 7 needs to come up to the top. So they're going to actually just switch places, just like that. And then when they switch places, you will end up with positive exponents, and you don't even need to write them. You can, if you want to write it 7 to the first and 4 to the first, that's fine. But that's what you get. You end up getting 7/4. Now I've got two more. These are also negative powers. So these are just a continuation of what I was showing you before. This one's pretty easy. It's just you have 5 to the -4th power. Remember, it's going to go into the bottom of a fraction. So it's going to go over 1 over and then 5 to the 4th power, just like that. Now, if you wanted to expand that out and figure out what 5 to the 4th power was, you can. 5 to the 4th is not 20. It's 5 times 5 times 5 times 5. And so 5 times 5 is 25. 25 times 5 is 125. And 125 times 5 is going to be 625. Now, the last one I'm going to show you is this one can be done in two different ways, just like the first one. And I'll do it in both ways and show you. The first thing and I think the easier way to do this would be to notice that this y is to the -2 power. So remember, if it's to a negative power, you're going to take the whole thing and make it switch places. So it's going to actually go down there to the bottom with its friend y to the 4th. And so because the whole numerator goes down, you can't just not write anything in the numerator. So what you'll do is you'll leave a 1 up there as kind of basically a placeholder, and you'll write y to the 2nd and then y to the 4th, just like that. Now, because these two things are the same base and they are multiplying, you can add their powers together and it becomes y to the 6th power, just like that. Now, the other way to do this would be to utilize the quotient property that we have. When you're dividing the same bases, you would subtract the powers. So you would end up with y to the -2 minus 4, just like that, top minus bottom. That would turn into y to the -6. Now, here again, we're going to utilize that negative exponent property. Because the y is to a negative power, that y and the 6 are all going to go to the bottom. And so it's going to get flipped over, And because everything goes away, we're going to leave the 1 up there as a placeholder, and it's just going to become 1 over y to the 6th. And what you see, as we did with the last problem, even though we used two different kind of sets of properties to simplify, we still ended up with the same answer. So either way is correct to do it, and I want to make sure I show you that there are multiple ways to do this. So that's what I wanted to show you today, guys. Thanks for listening. And as always, if you have any questions, feel free to email me. Have a great day.